Good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. In today's video, we're going to continue to question 3. So, it reads as follows. So, 3.1 says, consider the following geometric sequence. It is very important that you are given this, whether it is a geometric or arithmetic sequence, right? So, we have 10, 24, 256, 64. Now, 3.1.1 says calculate the 10th term number 10, term number T10 of the sequence, right? How do we do that? Remember, from the formula we have Tn is equal to AR to the power of n, right? So we have to find the value of A first, as well as the value of n minus 1 is the value of R first, right? Yes. So how can you do that? Finding the value of R is gonna be 256 divided by 1024, right? That's your value of R, and you'll get that your R will be how much? 1 over 4. All right. Then the value of A, it is your what? Remember, the value of A, it is your first term, right? So now how do you find the T10? We're gonna say T10 it is equal to A, which is 10, is 1024. R, what is R? 1 over 4 to the power of n. What is n in this case? In this case, n, it is 10 minus 1, right? Then how much do we get? We get a value of 1024 multiplied by 1 over 4 to the power of 9, which gives us the answer of 1 divided by 256. 1 divided by 256. This was a fairly easy 2 marks. Then let's move on. We now know the value of A as well as the value of R, right? Let's just note this down. A, it is 1024. Maybe we might need them later. And R, it is equal to 1 divided by 4. Now, calculate what this. Remember what's this? This is sum of sigma. Sigma is the same as the sum of whatever term numbers that they are talking about here. All right. So first thing first, let's find the number of terms that they are looking for. The number of terms. How do you get number of terms? Number of terms, you're going to say top minus bottom plus 1. All right. So what's top? What's top? Top, it is 8 minus what is bottom? Bottom, it is 0, then plus 1, which it is equal to 9. So it means the number of terms in this particular sequence that they are talking about here in this sigma, it has how many terms? It has 9 terms, right? So what I always say also is that when you are given sigma like this, your first mark will come from you determining the first 3 terms. Determine the first 3 terms. All right. How do you do that? You substitute P as whatever this value is here. So the first trial, you're going to substitute P at S equal to 0 in this equation. You get the value. Then you increase this number by 1. You get P is equal to 1. You substitute there. You get the second value. Then you substitute P as equal to 2. You get the third value. Then you are done. Then what's the importance of getting that? So that you can see which pattern you are having here, whether it is arithmetic or geometric or whatever. So the first 3 terms, if I substitute 0, I get 1024. If I substitute, remember it is a geometric series, so probably like this. Even if you use this, it's fine. Then if I input 1 here, I have a, if I input 1 here, I get 256. If I put a 2 here, I get 64. All right. So these are my first three terms. But now, can you see that this pattern here is the same as that one? Yes, right? So you needed to do these first 3 terms so that you can see if it is the same with this one. If it's not, then you have to find the value of A, the value of R. All right. So you all agree that for this part, this is 9 here, not A, right? 9. Then A is gonna be how much? 1024. Then R it's gonna be how much? 1 divided by 4. But remember I said when they say calculate, then they give you sigma. It's the same as saying calculate what? Sn. Sn. So what we are looking for, it is what? It is Sn. Alright? Yes. What we are looking for, it is Sn. Alright, let's do so. Remember this is geometric, right? So remember how do we find Sn for geometric? Sn is equal to A 1 minus r to the power of n divided by 1 minus r, right? Then, but we want sum of how many terms? 9 terms. We have determined that, right? What is our A? Our A it is 1024. What is the value of 1? What is R? R it is 1 divided by 4 to the power of how many terms? 9 terms. Then I close my bracket. Then I have what? Minus 1 divided by 1 divided by 4. Then the sum of 9 terms gives me how much? Let me punch that. Let me punch that 1024 into 1 minus 0.25 to the power of 9 divided by 1 minus 0.25. I get the value there as 887,381 all divided by 64. I prefer you leaving your answer like this, which is I prefer you to leave your answer like this. This is your final answer. But someone might approximate this and say, all right, the answer is therefore approximately 13, approximately 1365.333. This is approximately, but I prefer you to leave it like this. All right. Then let's move on to the last question, which is 3.2. 3.2, 3.2, 3.2. Now 3.2 says the first two terms of a geometric sequence are this one as well as that one, right? So determine the values of t for which the sequence will converge. Now, what you have to ask yourself is which condition should we have so that this series should converge? We know a condition is that the value of r should be between what? -1 and 1, right? That's the condition. So now we're gonna say, all right, let's just first find the value of r. R is gonna be this is term number 1, this is term number 2. You all agree with me, right? So R it is T2 minus T1, right? What is T2? T2 it is T3 T cubed plus 9T squared plus 27T plus 27 all divided by what? By 2. But remember I have to divide again by what? By this term. Instead of using the normal division, I'm gonna say divide by what? By negative T squared minus 6T minus 9. All right. Therefore, as we continue here, now I first look at this. Is this how many terms? 4 terms. Is grouping applicable here? No, grouping is not applicable. Why? Because it won't give us the constant thingy, right? It won't give us the constant thing. If I try to group, it's gonna be t cubed plus 9t squared plus 27t plus 27. I want you to see something. Then here it is t squared. Then I have what here? I have a t plus 9 plus 27. Here I have t plus 1. Can you see that this and this are not common? Therefore, if they are not common, I cannot apply grouping, right? The second thing that I think of is sum and difference of cubes. Yes, but in this case, it cannot be like this. Remember, if I have t plus 3 cubed, I'm going to say it is t cubed. Then I'm going to do what? I'm going to say, oh, actually, I'm going to start by saying, actually, if I have, actually, t, all right, t cubed plus 27 cubed, 27. It's going to be t plus 3. Then I'm gonna square the first one is gonna be t squared. Then I do minus this times this. It is 3t plus 9. So can you see that here there is no way that if I multiply out here, I want you to see something. It's gonna be t cubed minus 3t squared plus 9t. Then if I multiply this, it's gonna be plus 3t squared. Blah blah blah. At the end of the day, it's gonna give me what? It's gonna give me this. But now I want what? This. So if you know very well is that you can use calculus here. Remember, this is an equation for a what? For a cubic function. This is an equation for a what? For a cubic function. So the first thing that you want to find, assume that maybe the question says find the values of t, like finding the x-intercept on a cubic function, right? Something like this. So you're gonna find the value of t such that when you insert here, it gives you 0. All right. The value of t such that when you input in this equation gives you 0. It is how much? You'll start with 0. Obviously, 0 will give you 27. You start with 1, maybe you'll see it does not give you 2, it does not give you 3. Then you go back, reverse, -1, -2. But when you reach t, it is equal to -3. Therefore, this thing will give you how much? Will give you 0. Then it means you're going to use that one. You're going to use that one. You know, if you say t it is equal to -3 here, you're going to end up with this part equaling to 0, right? But when you come here, you're going to say t, instead of minus, you're going to say plus 3. Why? So that when I say equate this to 0, it's going to give me -3. All right? Then I do what? I say, what is the term that I can multiply t with so that it gives me t cubed? I want to put it here. All right, that term should be how much? Should be t squared, right? Then I say, all right, what's the term that I can multiply 3 with so that I can get 27? All right, you know that the term is 9, right? You can say 27 divided by 3, right? But when I come to the middle part is the one that's mostly challenging for many students. So how I do this, I do this. I say 3 times this one, right? 3 times t squared, it gives me 3t squared plus what? Should give me what? What has t squared here? It is 9. Should give me 9t squared. So I come back and I say again, what term should I multiply to t so that it gives me whatever this? Oh, actually, let me solve for this. We all agree that whatever in here, it should be 6t squared, right? So what is it that I should multiply this t with here so that it gives me 60 squared? I repeat, what is a term that I should multiply t with? This term that I should multiply t with so that it gives me 60 squared. You all agree with me that value it is plus 60 here. All right. All right. Yes. There is another way of doing this, but I hope I had time to show you that step, but maybe we can go through it. So for now, I'll just come back to it. So it is 60, right? So you see here, can I just start afresh? Now I say, firstly, take t, find the value of t such that when you substitute in this equation, it gives you 0. You get it that t is -3, right? Here it is, right? Then you do what? You take that into into a bracket. So it's gonna be t plus 3. So that when you equate this to 0, it gives you -3. Then you do what? You can square the first term and get t squared. All right. Then square the last term. Then here it is. The last term it is 9, right? But on the middle part, what you have to do, or you can do this. All right, remember I said you square the first term, you get t squared. Then you square the last term, you got 9, right? plus, you can say the first term multiplied by the second term multiplied by 2. But the question is, what will these two come out of? All right. So hence, I do not want you to learn that. Instead, I'm gonna say, after getting this, I just classify the first. All right. In this equation, t cubed is the first one, right? In this bracket, t is the first one. In this larger bracket, t squared is the first one, right? So let me repeat this again. I'm gonna say, which term should I multiply this t with so that it gives me t cubed here? All right. So that term should be what? T squared. All right. Then I move on. Which term should I multiply this last term with here so that it gives me 27? So we realize that that is 9 positive. But the middle one, I said is the trickiest one. I say the first thing that I do, I multiply this first two. I get how much? 3t squared. I say plus what? 3t squared plus what should give me 90 squared. We all agree that it should be 60 squared, right? So if that's the case, I'm gonna do this. If that's the case, all right, what should I multiply this t with here so that it gives me how much? It gives me 60 squared, right? I repeat, what should I multiply this t with here? With here, such that when I say t multiplied by that value, it gives me 60 squared. Do you all agree with me that this value here should be 60, right? Because when I say t multiplied by 60, it gives me 60 squared. Then you can try to foil this one and sorry. Foil this one and try to see if it gives you the same answer now as the original equation that we have. All right, then I'm gonna divide by 2 here. I'm gonna divide by 2. Then divide by what? Allow me to take. I can see something here. I can see something. Or actually, let's apply tip and times. Tip and times say if I multiply this, I change this sign from division to multiplication. I'm gonna divide by 1 of whatever that value is, which is negative t squared minus 6t minus 9. But do you all agree with me that I can cancel out this one and this one? But the problem is now the signs should be the same to apply that, right? So how can I do that? How can I change these signs to be positive, positive, positive? You all agree with me if I can take out negative as the highest common factor in here, right? If I can take negative as the highest common factor, you all agree with me, it's going to be like this. When I take negative as highest common factor, it's going to be negative into what? T squared plus 6t plus 9. All right. So if that's the case, I can now be in a position of saying, all right, this term can cancel out this term. But remember, this negative is left out, right? So I'm going to have what? I'm going to have I'm going with this slow because I know for some other reasons, some people need basics of this. So it's going to be t plus 3 divided by 2 multiplied by 1 divided by negative is the same as negative 1, right? So I know this simplifies to what? This simplifies to r. This simplifies to r being negative t plus 3 divided by 2. But now I know for this series to converge, I need this condition, right? I need that condition. So if I need that condition, I'm gonna say r should be between -1 and what? And 1. So I just substitute what is r. R it is negative t plus 3 divided by 2 less than -1 greater than 1. All right. Then what I'm going to do first, I'm going to multiply both sides by 2. When I multiply both sides by 2, I get what? 2 less than negative t plus 3 less than negative 2. Alright? Then I take this 3 and distribute to the other side. I'm gonna like minus 3 on this part, minus 3 here, minus 3 here. So I get what there? I get 2 minus 3, it is negative 1 less than negative t less than negative 2 minus 2, it is negative 5. Right? Then I know if I divide by negative 1, by negative 1, by negative 1, according according to inequality rules, according to inequality rules, when I multiply or divide by a negative, what? Signs change. What do you mean by that? It means when I divide by negative, it will be like this, signs change like this. But there is no inequality like this, so I'm gonna conclude and say therefore t is less than, then you swap these numbers. Alright? You swap those numbers, 2, 5, and 1. So this is our final answer. The question seemed easy, but it needed you to understand the principle of calculus first here, and then your algebra there of moving forward. So let's meet again on question 4 under this same question paper. Thank you.